Thanks so much. Um, yeah, thanks so much for the very, very kind introduction, Carlos, and even more important for like organizing this amazing event. It's been great fun so far. So yeah, thanks a lot for doing this, and thanks to all of you for stopping by and being so interactive. This is really a fun crowd so far. It's great. So yes, so this is the my I guess most fun part because yeah, we're bringing like these different layers of annotations together. So both like what we did yesterday in the feature-based molecular networking, as well as what Marcus just showed you was serious, right? And then technically, if you have any other preferences of annotating your spectra or putting some other sort of like meta information into it, that will kind of like also be the moment where we could bring in like those different annotations. And the principle is actually quite simple. So all we have is basically one big data frame where we have like multiple columns of like this annotations, right? And the simplest example would be you can visualize this in an Excel table and merge it in an Excel table. And I don't know, back in the old days, I was quite fascinated by Excel and became an Excel wizard. So that's what I would use, right? But now, as like scripting languages are more and more accessible, people probably do that in Python and R, and that's obviously like the more professional way to do it. But you can also do it directly in Cytoscape, and that I think for like the remainder of this session is what we're going to do. And what I basically will do is I will go back and forth between yeah, like different web browser elements and the software Cytoscape. And to just like bring us all at the same page, what I'm going to start off is like this shared Google Drive that I think all of you should have access, because all like the data I'm going to pull is kind of like linked in like this Google folder. And like the most important thing to start with is here is GMPS2 FBMN job link that Giovanni shared with you yesterday. So if you go and open this, then you should get this URL, and then you can just like open this in your web browser, and then we're gonna continue where Giovanni left you off yesterday. And as you remember, he gave you already a little preview how to like bring in like the data into Cytoscape, and this is exactly what we gonna repeat now, right? So here you explored like all like the network visualization in the web browser, but now in this session we're actually gonna go to like Cytoscape to do that. And how I typically download it is here through like this download all results button, which then provides you also all like the raw tables, which can be a little bit confusing, but I think if you like want to do some advanced stuff, it's handy to have that. Or you can download here the GraphML file, or you can also use like this network export option in Cytoscape, which will create a .sys file, which is kind of like the same network. I would recommend to either use the GraphML or download all results, because the like time it takes to build the .sys file is a little larger. So for speed reasons, just like click on download network GraphML, and then be careful to not download like the ones without the singletons, which is not super intuitive, but there's one download network GraphML. This is only the networked nodes. And then there's the download network with singletons GraphML. And as some of the annotations we want to merge may have not a network connection, this is the one I would recommend to download now. So I can just save this here in like my Eco-Metabolomics folder, and then hit here save, and then hopefully as like now 60 people are in parallel downloading it, it will not take us like too long. And just to, as a backup, I already downloaded it before, which you eventually did not. Okay, so, and I have it here under this GMPS download folder. Now what I did here is I actually downloaded the full process job. Maybe also to give you just an overview how this looks. It can be a little bit confusing because there's a lot of files in there. But once you get used to like the naming, then maybe it's more intuitive. So if you download only the GraphML, it will be only one file, hopefully. But if you download the full thing, then this GraphML will be in this NF output folder. And F stands for next flow. So this is the workflow manager that kind of like runs behind the scene. And then if we go in, there is this networking folder. And then you will actually see that it directly downloaded both like the network with singletons and the network without singletons. And on the file size, you can see already that obviously the one with the singletons is larger because it has more information. I think that caused some confusion yesterday. Hopefully that will explain it now a little bit better. Okay, so this is just about like the basically, files we're going to work with. Oh, one other thing we will need is the serious summary files that Marcus just generated with you. So those are also in the Google Drive. If we go back here, and then there's the serious folder, and then there is the, oh, sorry, serious project space, and then reprocessed, right? And then there is like here the serious, oh, oh, okay. So yeah, there's the summary file folder, which you can download. And that, I mean, we can take a look already on here, will like basically contain like this different layers of annotations. So molecular formulas from Sirius, then like the structure annotations from CSI finger ID, and then like the class level annotation from Canopus. While I'm talking, if you want to download it already, I would recommend this. So you can either download them individually or like the full folder, and then it will just generate a zipped file, and then you have to unzip it on your computer. Okay, so that's what we need in order to move on. And now what I want to show you very briefly is just like a kind of background of Cytoscape, because this is the tool we're going to use. So who of you has used Cytoscape before? Okay, cool. Cool. So like people are quite familiar. So if you have not used it and your neighbor just rose their hand, so maybe you can also look at them in case you have like any small questions. If like you're stuck, also feel free to interrupt me, and then we can discuss it during the workshop now. So this is supposed to be very hands-on. But okay, so Cytoscape is an open source tool, and it basically allows you like to visualize networks. It's very much used in like the genomics and other omics sciences, and it's a fantastic open source tool for like network visualization. In my opinion, the best one I know of. I don't know if you have other recommendations. I'm happy to learn about them, but so far we've been using this for years, and it's really cool. Okay, it's developed by multiple institutions, so it's like I think a community effort, and it's great. And yeah, like it's constantly updated, and there's a bunch of like different like app stores. So you can like download additional apps and expand the capabilities in there. Okay, great. So now, yeah, basically people use it for, I don't know, multiple visualizations, metabolic pathways, interactions, correlations, it's very common, and similarities, right? So in our case, we now want to show spectral similarities, right, in like those molecular networks. But I use it, for example, also to like integrate my meta barcoding data or shotgun data and correlate ASVs and molecules, right? So this is something you can like nicely do in Cytoscape as well. So there's really like a lot of like opportunities, and this is what we do here is really just like the very, very basic. Okay, and then what we want to end up with is basically something like this, a global molecular network, and then we can zoom in and like explore like this molecular space. Now with GMPS2, there's tons of opportunities in the web browser as well, as Giovanni showed you already, right? So if you want to just have a very quick visualization, you can probably also do a lot of the basic stuff directly in the web browser, but then at least, or the latest when it comes to like integration of your serious results, then you cannot do that there anymore. And then, yeah, we would recommend to move on to Cytoscape. All right. So as I mentioned, there's like the core app, and then there's like the app stores. So you can like download different like apps. So I, for example, use like the ChemVis app, which allows you to display directly structures over your notes. We can like maybe try this later if it works. And there's a bunch of other apps. Like there's some for like correlation analysis directly in Cytoscape. And yeah, so feel free to explore those and I don't know, test them out as you need them. Okay. And then, okay, this might be a little bit outdated. I don't know if it's still 3.10, but if you have not downloaded it already, I would recommend you now to like download Cytoscape, either for Windows or for whatever OS you have, and then fire it up. All right, so I launched Cytoscape now by just like typing it here in my task prompt, right? If you have a desktop symbol, whatever, you can just launch it from there. And then what you should see is basically the Cytoscape software. So now, before I load in the GraphML file, as Giovanni showed you yesterday, I just want to go through like a little bit the basics of Cytoscape in case you've not used it before. So what we have here is like this drag and drop area at the moment where I could drop the GraphML file. But then also like here in the middle, I have like some previous networks and some example networks that I could just like open as an example. And then at the bottom here, I have like this table view, right? It says node table. And those are kind of like the different elements that I'm gonna use. So as soon as I generate a network, for example here through file, new network, empty network, then it will basically now display this network here on the left under this network tab. And then I will have a table and I will have here a network view, right? And what you can see here is that there is nothing because it's obviously empty. But if I would now want to like do some visualization by myself, I could just like add like a node in here, right? And then add another node and then eventually add edge and then connect those two nodes, right? So I can build networks in there myself, right? And as you see, what happens is that now at the bottom here, these two nodes are displayed in this table. And this is a really important thing to keep in mind to like go back and forth between like the table view and like the network view. And for me, this is very intuitive because at the end, this table at the bottom is nothing else than the feature table you generated with Steffen, right? So, and then the data frame, what I mentioned before, right? So now if we have additional annotations, such as from series, we can basically add on to those tables. And this we will do later through like this like import function. And yeah, I think as a very basic, this is really important. So like the network is on the left, then visualization of the network is here on the top, and then like the table view here is on the bottom. And then also I can switch between node-centric view and here an edge-centric view. And as Giovanni mentioned here, these numbers next to the network, they indicate basically like the number of nodes and the number of edges, right? And I can look in the table at both of those. And now depending on, you know, what way you look at your network, then either of those views might be beneficial. So in the past, for example, when we looked at biotransformations, I was like very interested in only looking at the mass differences between those nodes, right? Because they tell me something about a putative biochemical reaction. So then maybe this edge view is like helpful for me. Whereas if I'm just interested what molecules are in my sample, then maybe I want to like look at it in a node-centric way. And yeah, so it's basically all about different tables. And also coming back to like this output files, when we go in there, right, then you will find like this network edges and this nodes also in the table view in there, right? And that is here filtered pairs, for example, right? I could open that in Excel and then look at like those interactions. And I think it's really intuitive to like actually look at it that way, right? Because all it says is like that feature 2691 and feature 2885 are like connected in the network with a cosine score of 0.96, right? So in the old days before this auto-generated like the GraphML files, what you actually had to do was like you had to import this like table into Cytoscape and then manually build the network. So now we want to make things easier for you, you know, and like just provide you a file you can drag and drop. But I think it's also important to understand the data structure behind, because then you can come up with new visualizations. And ion identity networking, for example, like that Stefan also highlighted, that builds up on this concept. Now, just in addition to like this MS2 similarity edges, we now also have like this coelution profiles, right, which we call ion identities, that we can like bring in there. And then what we did at the beginning was we would just like basically scroll to the end of this table and then add like new connections in there, right? And then just say, well, instead of like here network node 1 and network node 2 correlate, and then we just would like create a new column and then call this like an IIN edge and then provide like the Pearson correlation score or whatnot, right? So, and that way you can expand this by yourself. Now, if you want to display correlations to an ASV, you could also like add this to this table and then bring it into Cytoscape. So, okay, long story short, like take a look at these files so you better understand what actually is visualized in there. But as I mentioned, we made things like easy. So if you want to get started, all you can do, or all you have to do, is like take like this GraphML file here and then drag and drop this into Cytoscape. So really I just like put it over here on like the left, and then it should import like this network now. Okay, I think this is now on my computer side, not on the internet side. It's slow, but fortunately, it did it, and like now we can like see like the network here on the right. Also, that network I generated before is still displayed here. This GraphML file here, so like the network singleton file, in case you downloaded the full GMPS2 folder, in case you downloaded the GraphML file, then I think I did that in the meantime. Then it's here, this Eco-Metabolomics workshop GraphML file, right? So depending on what download option you used on GMPS2, whether it was through download all results or just download the GraphML file, you either have this full folder structure I just showed you, or you only have the GraphML file. So who of you managed to download the GraphML file by now? Okay, who did not? Okay. This one, you can do that too. I personally don't like it because it takes really long to build it. So I rather download the GraphML file. So if you do this here, then it will download a .sys file, which is also basically, you can also open it. So it also works. It has also like this preview and it's more fancy, but I think the download GraphML here is more slim. And then, yeah, make sure to download the one with the singletons. All right. Okay. And then, yeah, all you need to do is basically take this GraphML file and drag and drop it into Cytoscape here on the left in this panel, right? And then depending on how many networks you opened, you can like navigate between them. So like my dummy network I created at the beginning will be still there, and then I can just switch between them. That also has the advantage that you can make subsets of your networks. So as I explore my data, I actually generate like different subnetworks. So I don't have to always zoom in the network somewhere, but then I just say, okay, these are like the interesting compounds I found, and I create a new network. If you want to do something like that, then the way I would suggest this is, let's say I'm interested here in this subnetwork, then I mark them, I right click, select first neighbors, for example, to like make sure I have them all. And then I can say file, new network from selected nodes, selected edges. And then what it will do is it will create a new network here in this tree, in which now only those selected nodes were displayed, right? And now if you find another interest, so I don't know, I can rename this and say, let's call this interesting features or nodes 1, or you call it whatever. Oh, I found surfactant, right? That's would be the obvious naming. And then I can, move on. Oh. So yeah, basically I can like kind of structure a little bit uh, my network and my results. And then also if I want to save it, right, then I can like save as. And then typically the Cytoscape default session files is .sys. So that's the different. The GraphML is more like a generic like network file, whereas here the default file would be .sys. So then I can, I don't know, call it network workshop one. And then every time you open it now, it will, you know, open with like all like the those sub networks. So this is good to just like, you know, not lose like all the process you made while you explore this data, which I think can be really overwhelming because like remembering at what location the network was and that does not work well. Um, I put control and then I just like box it. Yeah, you can also click on them individually, but if you want to box an entire network, then you hit like control and then you can like create like a box. Okay. Other questions so far about Cytoscape? Okay, you all managed to download it and you all managed to drag and drop into Cytoscape and see now this network. Okay, cool. Then maybe let's start fusing in data before we go into like the style. So we just have like our data frame complete. And then we can like do some visualizations such as like the pie charts Giovanni showed you already yesterday. Okay, so again, important to remember networks overview is on the left and the visualization here on the top, and then my table view is here on the bottom. And as you can see right now, I'm in the edge table, right? So those are like all the interactions within my network. I see what I showed you in the Excel table. There's a score, which is like the cosine. Then there's a delta mass, right? Things like that. But what I want to do now is I want to look at it on a node-centric way. So I switch here to node table. And now you will see that all like this attributes from your metadata from yesterday, you know, is in this table. And now one problem I have is that I just like lose track of how much information is in there. So now what you can do is you can here actually define what columns should be displayed. And what I would suggest is at the beginning, if you are not dealing with like the attributes, you know, say select none, and then maybe skip most of them and only like put like some meaningful information for you there, right? So what I typically want is like the mass and the retention time. And then I want to like know what like compound names those are, you know, and then maybe I want to have the shared name, which is like the node number from the feature table. Okay, and then yeah, if I only check those and I click elsewhere, then this table will be already like more digestible. I can now sort, you know, by clicking on the headers, and then I can hopefully quickly see what molecules were annotated in there, right? And as the very, very basic way of exploring this, I could now look at like some interesting compounds, and there's like this methyl melamine derivatives, which I know already is like a xenobiotic family that was in this data set. So I could now navigate and go to those. But okay, I mentioned we want to like merge now the data in from series. So how are we going to do that, right? And now maybe to just give you an idea on how the series data frame looks like. So we can go back to our folder here and then yeah, make sure to download like the summary files. So these TSV files, right? And then we can like just open them really quick in Excel and have a look at them. And here I did this already and I extracted them. So they come as a zipped file as well. And then, yeah, I basically see now here like this different TSV files. And I think like the most confident and probably most basic information you will get are like the molecular formulas from series, right? And they're called here formula identifications. And if I double click on it, then hopefully it should open in Excel. if you do not have TSV files as a kind of like selected file format for generic visualization in Excel, you can also drag and drop it into Excel if this does not work. All right. And then now, again, like this big table should be loaded. And then you should see all the information that is written in the summary files. And now I'm very happy that after many workshops we did together with Markus and the other serious people, we realized that merging it makes a lot of sense, and they made it even easier by directly providing the feature ID here as an individual column. And this is kind of like the anchor you have in your data frames, right? Because this is the same number as you have in your feature table, as you have in your feature-based molecular networking outputs, right? And now, if you know the, what is it in German? It's S-Verweis. How's it in English? The merge function in Excel. VLOOKUP, right? So you could use like the VLOOKUP function and actually stitch like the tables together directly in Excel, or if you're in R, you can use the merge function there, or we can now directly merge them into Cytoscape. And to do that, we go back to Cytoscape, and then we go to File, and then Import, and then say Table from File. And now I'm gonna just navigate to exactly this table under Serious Summary Files, and then I select here Formula Identification. And now by default, it basically pre-selects all different columns that are in like this data frame. And now all I need to do is I need to tell it what is the anchor of that data, right? So it's here, it's represented as a key. And obviously the key is not the molecular formula, but it's like this very last column here, the feature ID. And now I could also, already be a little bit mindful about what to import. So there's a lot of information in there. And actually, I may just want to have one of them. So I could say select none and then only say, okay, give me the precursor, molecular formula, and then say, okay, the feature ID needs to be the key. And now if I want to have the scores and all the other information, I could also select them. But for simplicity reasons, I just going to import now the molecular formulas. And I say, okay. And then now magically, I should get a new column with like the molecular formula from Sirius. Right? Very, very convenient. And now I can do, of course, like the same thing by importing the other information, let's say from like the compound identifications. So this would be the CSI finger ID information. And again, let's select none. And then what I want here is basically the names. And then I want the smiles. So this is the code for the structure. It also has things like log P, which is cool. So I can already think about whether that makes sense, with regards to retention time. And then I want a confidence score. Markus, how is it called? Confidence score. So here we have the confidence score, because especially for the CSI finger ID results, I'm always a little bit skeptical. And the false discovery rate is perhaps not as good as it is for like the library hits, and definitely not as good as it is for like the molecular formulas. So it's really important to like keep in mind that these are like different levels of annotations we're dealing with, and some of them are like more confident than others. But anyway, so now I'm gonna upload. Oh. Sorry, can you repeat the question? Okay. So who managed to upload these tables now to Cytoscape? Okay, some people who are still struggling. Okay. Do you want to say what you're struggling with? And maybe we can troubleshoot it together. So the first table I uploaded was here, this formula identifications. Let me just repeat it really quick. So I went to File, Import, and then Table from File, right? And then I selected this formula identification file. And then I was, basically first hitting Select None here on the top right. And then I just selected the molecular, the precursor formula as an attribute. And then most importantly, I selected feature ID as the key, right? So this you always need to do. So like the software knows what is like the basically connecting information in here. Exactly. Feature table. Yes. Yeah. Yeah. Okay. So maybe just to repeat the question. So here feature ID, this is the merging column, right? So this is basically the number that needs to be the same as your shared name in Cytoscape and as your feature ID in the feature table. And you just need to tell it by setting the key to feature ID. Exactly. So that's the scan number in your MGF file. So it's, feature ID is always like the connecting element between the different layers. Okay. I mean, I kind of would import probably all and then just display specific columns. But now for simplicity reasons here in the workshop, I only imported the molecular formula here. So the table does not get like too overloaded, right? You can of course import it all and then only display the relevant ones for you later in Cytoscape. But now I just quickly imported here the precursor molecular formula. And then I hit OK, and then it should load it, and then it should appear here as a new column, right? All right, and then I did the same for file, import, table from file, and then I did the compound identifications, right? And then the same way as before, I need to select feature ID as the key, and then any column that I want to bring in, such as the smiles and compound name, I bring in as attributes. All right. And then I hit OK. Yes. Yep. So it's called shared name here because this is the shared name between the different data frames, right? So that's the merge thing. Um, yeah. Okay. So now we imported the molecular formulas, right? We imported the compound names and smiles code from CSI Finger ID. But there was another layer of information we got, which was the class level annotations from Canopus, right? So now I just need to import one more table, and then I think we're done for like at least the information from Sirius. So again, to do that, I go to File, Import, Table from File, and now I select the Canopus compound summary. And then just as before, right, if I hit here, select none, then I can select the feature ID as the key, and then I can select the different classifier levels as my attributes. Okay. Then you did something wrong. So the question was what's the error when you hit when you get no rows imported, then something maybe went wrong. I would assume to double check the key, right? That you like selected properly, like this feature ID as key, and then yeah, make sure that you select the rest as attributes. Sometimes there is problems with like the different numeric values you get. So whether something is like a float value, or not. So if it's numbers, then be mindful about like the type of value. But I think for now here, these are all just like strings, right? So it actually says it when you hover over it. So those are just string values, and it hopefully should be fine. So this was the cannabis results. So this was the last one. So now, yeah. Again, I will hit OK. And then now, like the different cannabis levels should be imported as well. So classifier is basically the ontology, the chemical ontology we're using, but there's also another ontology and some other like class level annotations. So feel free to browse through those and pick the one that seems more appropriate. I think especially for like some natural products, there might be like the natural product ontology that might be um, more useful, but I by default use like the classifier ontology. And then, okay, so now we have like all like these different layers of information together in here, right? And I think this is really like the key of like this session. So if you have any questions about how to bring in like an additional table, so now is the time to bring that up, because I want to make sure that all of you get to at least like that point, right? Because this is really what enables you to like use like Cytoscape as a central merging tool and visualization tool for like the multi-layer annotations you may have. Okay, so just to get an idea, who of you got to that point and was able to at least merge in one of like the serious output files? Okay, so at least half of the people. So who was not able to do that? Okay. Do you want to either check with like one of your neighbors who was able to get it done and double check? And then Giovanni is also walking around and can actually give you a hand with it. Okay. Are there any questions so far you think might be relevant for like the entire group? So, okay, the question was whether we do need all of them. So this really depends on your project and science, right? So I typically just for completeness, just merge them all in. But if you're say, well, I don't believe like the in silico annotations, and I only want to have molecular formula level here, then obviously only import the molecular formulas. Okay. Any other questions? All right. Shall we continue then for now? And then if you couldn't manage to like get to that point, feel free to uh, talk to us like after the session and we can like look at your particular example. But yeah, so to stress once again, we imported like the different like layers of annotations from Sirius, and now everything should be here in this table, and then now some of them you can see are already annotated also like on top of like the notes. So this is now simply depending on my style and the visualization of like the network. And now I just want to showcase really quick a couple of like the ways we can now customize here our network, right? So if we go to style, to the style tab here, then my network view will be replaced with like the style view. And yeah, Giovanni showed you already briefly yesterday some of the things you can do here. And the most generic thing would be to now change the label, right? And instead of name, use, for example, like the mass. So I could go to MZ and then select this with the mapping type pass-through mapping. And then what you should see is that now every node here has like the MZ value as a label. And if you click on them, you can move them around and now kind of like structure the network as you wish, right? And kind of like think, oh, what might this compound be? Now, of course, like the mass, well, I think for me as a mass spectrometrist, it's like a very generic and universal characteristic. It's not necessarily meaningful for you in a biological sense. So, but then you cannot, of course, also now label it by, I don't know, like something else, like compound name. Oops, here it's library compound name, right? And then, we would see there's no labels in this network. So we actually have to zoom out and zoom to like the few that have like an annotation. And this is simply due to the fact that like most of those nodes are not annotated by the GMPS spectrum library matching, right? So here there's like some sugars. And then if I move like to some other networks, I see there are some more compounds annotated. Here is like this lyso-PC phospholipids, which is like a nice cluster. Okay, and maybe some more over here. But yeah, it's not very universal, right? And this is like really the point where I think importing like those serious annotations is just like so powerful, right? Because it provides you this different layer of annotation. So now instead of like compound name, I could, for example, then use like the precursor molecular formula, and then bam, I already get way more annotations, right? And now, of course, like from a, like biochemistry perspective, this is not necessarily super meaningful because this can be like many, many compounds. But if you're interested in elemental cycling, or you just want to have a rough idea what like the things are, then I think this is already very, very helpful, right? And when we zoom out, you see that actually many nodes here have like annotations on the molecular formula level. Although there's also some networks, where also like it's unknown on this like, molecular formula level. So this might be like the interesting weird stuff that is not considered by like the elemental constraints from series. Okay, so now what about like the class level annotations? Okay. Yeah. Yeah. Important thing. Marcus just mentioned that he cut like the molecular formula annotation at 900 Thomson, right? So at 900 M/Z. So they may be just like bigger compounds. We can of course quickly check this by switching to MZ, and then surprise, surprise, maybe it's not that new stuff, but just like larger molecules that were not considered in series due to like computational constraints for larger compounds. Okay, so now there's of course like this other layers, okay, of information. Just one second. Okay, question is, what if we see like the same compound multiple times in a network? There can be different reasons for that. Like the most generic one is that you have like some like stereoisomers, right? So like there's maybe some structural differences on an isomeric level, and you get different retention times, but the MS-MS spectra are kind of like the same, right? So then you would get to the same annotation for like the two isomers. Another explanation is that you have artifacts. Unfortunately, the feature finding is not always like 100% accurate, and sometimes peaks get split into like two features, right? And then they would still have like the same MS-MS spectra, and then you would have like the same annotation for like all of those. One way, in case you find something, I mean, I think that sugar we saw earlier would be an example like that, then I would check the retention time, right? And see, are like the retention times far apart? And if that is the case, then maybe they're like truly different peaks. Then I would generate some XICs downstream to actually verify that these are like truly different peaks. And if the retention times are very close to each other, then it's probably an artifact from feature finding. Okay, but to move on, So now we have also like the class level annotations, right? And now I could also like display those, right? So instead of like MZ, I can use like the classifier superclass, and then, oops, yeah, and then get here like the different like classes. Now, this is of course maybe not like the best way to waste your label by just like the class, right? So like one thing that I like is actually I color the nodes then depending on like the different classes. So to do that, we would use here fill color as a mapping option and then just like expand this. And now here select um, our classifier superclass or subclass as like our attribute. And then I select here discrete mapping as like my way to do it. And then I see already, oh, there's many different variables. So maybe I cannot select sufficient colors to do that efficiently. So then I would go one level higher to superclass, and then I have like less variables. And then I can select now here different colors to then indicate which nodes are what. Okay. See, I'm just gonna do it for a couple now as an example. Oh, how do you do that? Amazing. Thank you so much, Marcus. You will save me hours. Okay. So, okay. Marcus just suggested to like generate the values automatically. And he said that we just select all and then right click and use the mapping value generator. And then we can like use different schemes. I think be mindful with like rainbow. Sometimes it's hard for like color blind people to see them. So use whatever color scheme you find most appropriate. But yeah, bottom line is now we have like the different nodes here labeled depending on the class, right? And now obviously this provides us already much more information and like helps us to better structure the molecular space we're visualizing in Cytoscape here. All right. Any questions so far to like the mapping at this point? Okay. Now, with regards to prioritization, there's of course like now different levels I can, like look at this, right? So like now here, chemical properties or like, I don't know, structural identities, this is one way. But then I can of course also say, well, I just mind about the compounds that are really abundant because I want to do compound purification downstream and I don't want to even deal with like the trace amounts of something that is in there. So we could now display the size of the nodes according to like the intensity. So how do we do this? We go here to first like this lock width and height button, and I just gonna lock them. And then I can use here size as a mapping type. So now to do that, I select the precursor intensity. Was it some? Oh, okay. Okay, now as we're in GMPS2, we lost a feature, but it doesn't really matter because we have like the intensities from our different attributes, right? So now I could say, okay, let's check sample area, and okay, I want to say what is abundant at the La Jolla Cove, for example. And then I could use a continuous mapper as a mapping type. And then just say, okay, like when I double click on it, like give me like the biggest like nodes for like the biggest precursor intensity. Okay, so then I just say, okay, I set this up here. And then now you will see that actually when I zoom out in my network, I will see that some nodes are like larger than others, right? According to their intensity in this particular category. All right, and I can also make this really extreme. And then it becomes very obvious what is like the most abundant feature at this different location. And let's see what it is. It is acabrose, sugar, I assume. Interesting. All right. Now, this might be also the point where we want to do some little hacks to this, right? Because as we lost our sum precursor intensity in GMPS2, that is typically a value that I really do like, right? Because it's kind of like the sum of your feature table. How could you get this back into Cytoscape? It's not there anymore from GMPS2, but we kind of like have this information from our feature table, right? Because initially, you remember, like there's like this long data frame that Steffen generated with you. So kind of like we have all the information. Now, the only thing we technically would need to do is sum this up manually and then add it to it, right? And I think if we actually can do this as a little extra and go back to the Google folder, then I could download now the feature table from Steffen. And Steffen, can you tell me, is this the right one here under reprocessed? Okay. So then I want to have basically here the GMPS quant table, right? And I quickly download this. And then I have now this additional CSV table, right? That again, I can open in Excel. And now technically I could also import this into Cytoscape, but before I do that, I actually gonna do one super simple thing. I just gonna quickly generate here a new column and generate my sum precursor intensity manually because I like it so much. And I'm mad that Ming removed it. And then I will just do now some very basic Excel operation and just build the sum of all like the peak areas, right? And then fill this down. And now technically I have this value I need, right? And now because I showed you earlier the trick how to import this, I can just like import this as a new column, no questions asked, right? To do that, I would actually now copy this into like a new table, paste as values, and then just save this as a new file. Save. And then I call this here sum precursor intensity. So here, like a new file appeared. Then I actually close this. I don't need it anymore. And then if I go back to Cytoscape, I can now file, import, table from file. And then instead of like the serious tables, I can select now here the sum precursor intensity. Right? And then I just say again, here my row ID, this is the key, right? So this is the feature number, the same way as it was in the series import. And then the sum precursor intensity is here like the value. And then I hit OK. And now, in addition to my attribute-based peak areas, I should now also have my good old sum precursor intensity as a value. And then now there obviously much bigger, so I maybe have to adjust a little bit here the mapping. And then I now can also tell you what overall in my data set is the most abundant feature. Let's see what it is. Let's use this. Okay, that's the first one. Oxosteroids, and it does not have a library compound name. So we will just go to the second most important one, or like most abundant one, and it is contaminant septum vial thermo C4000. Okay, that's great because that's like a very like general contaminant we see in every injection because it comes from like the septum from the vial. We may can even use this as an internal standard now. Great. Okay, so that's for like the size mapping, color mapping, naming, and import of like additional information. Now, I don't know if you already think about like ideas, what else you could import in your own data set, but tomorrow Upser will generate some like statistical values with you, you know, such as like ratios between like different sample groups or p-values or random forest mean decreased accuracies, you know. Obviously, all these values you can also import the very same way as I just showed you, right? And then pinpoint you directly to eventually like the features that matter for differentiating like, I don't know, like two biological groups, or in our case here, sample locations. So there's really like a ton of like other possibilities. But okay, to just like show you one last mapping type, because I think that caused some confusion yesterday, and I also think it's a very useful mapper. Let's generate again like these pie charts that Giovanni did yesterday. Right. So to do those, we want to go to like the image chart option here, and then click on like the default value. And then we can have here images, charts, or gradients, right? And then I select charts, and I select here a pie chart as a visualizer. I can also use here this ring chart or like bar chart, so feel free to play around with it, but like we typically like the pie charts best. And then, yeah, you just need to select now like the different values that you actually want to display. So here there's already one selected. I don't want that. So I remove the selected one. And then by, yeah, going through here, I can now, you know, select like the different metadata groups. And there's already one that seems meaningful to me, which is here like the different locations, right? So I would select here like the different sampling locations. But yeah, in general, this really depends on, you know, what your biological question is, right? If you have like two groups of like treatment, you want to compare healthy versus sick, or like control versus treated, whatsoever, then obviously you would select those. And then we can customize here then the colors. Now I'm curious if Marco's trick also works here. Probably not. Too bad. That would have been amazing. But I can probably, yeah, then yeah, use like the color panel here. Nice. Okay. And then assign these colors through like those numbers to then like the different like attributes. I select it, and then I hit apply. And then now if I zoom in, now in addition to like my background color from like the nodes, right, I also have like now the pie charts on top of them. And now I can quickly, you know, with like the pattern recognition of my brain, say, oh, this network here is mainly red, right? So this may be something that is more unique to like a certain sample location. Whereas other things that were after full rainbow, you know, they seem like more universal in this data set. Okay. Any questions for the pie chart generation so far? All right. So then, okay, to wrap this up, there's many more other mapping options that I think going through all of them would be way beyond like this 1 hour sessions. But I just want to, you know, highlight again, you know, to like play around with them. and then, you know, try them out. So yesterday, Giovanni also showed you edge mapping types, right? So you can switch here on the bottom between node and edge, and then, you know, quickly change like line types for your ion identity networks, right? Or the color, or also like the thickness of like the edges, depending on like the cosine score. So there's really like a lot of like different possibilities. Okay, I guess that was a lot. And at least I'm ready for lunch. Um, are there any questions so far? Then if not, happy to talk with you all afterwards. And if you have trouble also, we can maybe also look at some examples then.